Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel, everyone. Today we're going to be working on the question, which is the square root of x squared plus 4x equals to x squared plus 5x plus 5. Before I start solving this question, I just want to say good luck to all the students that are studying for the International Mathematics Olympiad competition or exam coming up soon. I wish you guys all the very best, and this video is definitely dedicated to you guys and to anyone who is trying to learn the topics that are covered in this question. So you have x squared plus 4x plus 4 enclosed in a square root equals to x squared plus 5x plus 5. So there are two ways of thinking about this. The first one, which is the common way to think about this, at least the way I thought about it, is x squared plus 4x plus 4, right? And we're supposed to solve for x. So I'm just rewriting the question for now. The first thing many students do is to square the square root. And because we're squaring the square root, we also have to do whatever we've done on the left-hand side, we have to do it to the right-hand side, right? So we end up with, you have a square root, right? And squaring a square root is going to basically cancel both the squared and the square root, or basically neutralize it. So what you end up with is just whatever was enclosed or is enclosed in the square root. So you end up here with just x squared plus 4x plus 4. But guess what? Because we did the same thing on the left side of the equation to the right side of the equation, we end up with x squared plus 5x plus 5, right? Multiplied by x squared plus 5x plus 5. Interesting. So this is what we have so far. Now, if we want to solve for x, we have to expand what is on the right side of the equation, where you have x squared times x squared, right? And you do the same here, and then you do the same here, and then you do the same thing here, and then you keep on doing that. At the end of the day, what you end up with is an x squared plus 4x plus 4 equals to x to the 4th. You end up with a variable that has a power of 4. Like you guys can see, and you also have another term with a power of 3. So at the end of the day, what you end up finding out is the fact that your question just became much more complicated. That's not how you deal with math. Math involves simplification so you can get an answer. Math does not involve making your work much more complicated than it needs to be. So that's the first way I thought about it. I got stuck, realized that's not how we're supposed to do it. Then I tried a different method, and as you can see on the screen, I rewrote the question, right? Which is the square root of x squared plus 4x plus 4 equals x squared plus 5x. So the next thing I did is to basically think about the question. X squared plus 4x plus 4, right, is the same thing as x plus 2 multiplied by x plus 2. So when you expand x plus 2 and x plus 2, what you end up with is x squared plus 4x plus 2. But x plus 2 multiplied by x plus 2 is the same thing as x plus 2 squared. Hence, we can put x plus 2 squared in the square root, and you can cancel out. So what you end up with, that, right, equals to x squared plus 5x plus x. Now we reach a point where we have to think about what's going on here. We have a question where we want to figure out, first of all, we already found what we were looking for, but when we were done doing the square root, we ended up with an absolute value. And that could confuse some students, like, where did this absolute value come from? Well, this is the general rule for absolute value. For those of you who may not know, the first is the index number, or the number of the index. The index number has to be even, okay? The power of the variable enclosed in a root must be even. And the last rule is the power of the variable gotten after applying the index, gotten after applying the index, or basically applying the root, has to be odd. So from this you can see that we have even here, we have even here, and we have odd. So now we have to, since we know this rule, for those of you who don't know this rule, please write it down somewhere. We see that in this particular question, the index number has to be even. What is the index of a square root? The index of a square root is 2. Because whenever they ask you for the index number of a root, what they're asking you is, what is the number outside? In a square root, you don't really show it, but if, for example, if they ask what is the index number of this particular, say, question, right? The index number is 3 because it's a cubed root. If they ask you what's the index number of a fourth root, is 4. They ask you what's the index number of a fifth root, it's 5. So in this case, it is 2, and 2 is an even number. So we're getting there. The power of the variable enclosed in the root is 2. Because we have x plus 2 raised to the power of 2, and x actually has the power of 2, like x squared. So this works. The power of the variable gotten after applying the root has to be odd. So when we apply the power, when we apply the root, so in this case a square root, we ended up with x plus 2. What is now the power of the variable? The power of the variable is 1, right? Because the power of x is 1. Hence, that's where we find out that this is odd, because 1 is an odd number. Hence, this is, so that's the reason why we just have to put this. If all of these 3, they did not work out to be correct, like all 3 of them did not work out to be correct, because you need all 3, you cannot have an absolute number. So for example, if it was not a square root, it was a cubed root, you cannot have an absolute number. If the power includes like the power of the variable enclosed in the root is odd, you cannot have an absolute value. I just want to teach you guys this for those of you who maybe have not been taught. That's how you work with absolute values. So I'm going to rewrite the question now, and we're going to solve it. So you have that, and then you have x squared plus 5x plus 5, right? Now x squared plus 5x plus 5 equals to the absolute of x plus 2. So now whenever you're dealing with absolute values, you always have to understand that the presence of an absolute makes something positive. So that means this entire thing, when you apply the absolute, what you're going to have is a positive number. But guess what? The variable x here usually can either be a positive number or a negative number. Just like if you're asked, for example, what is the square root of 2? You know that's 4. What is the square root of negative 2? That is positive 4. It does something similar to what a squared would do. Very, very similar. So it's important for you to know that when you have an absolute value, it makes whatever is enclosed in the absolute value to become positive. But that doesn't mean that the variable that is inside, or even just the number that is inside, is actually a positive number. So if I ask you for the absolute value of negative 12, that's 12. The same way, the absolute value of 12 is the same thing as 12, right? Or the absolute value of x is x. The absolute value of negative x is actually positive x. So that means x can either be negative x or positive x. Do you understand? So I just wanted you guys to kind of know that, because that's going to be very important as you go on to do the solution to this question. So you have this here. Now we know that we can have 2 values for x in order for us to be able to go on. So we have a case where x is going to be less than negative 2. Okay, so x is going to be less than negative 2. Because if we have a negative 2 here, what we have is 0. But if you have like if x is like a negative 3, right? That would be negative 3 plus 2. which is going to be -1, and the absolute of -1 is also 1. So you have two cases where x is going to be everything enclosed in the absolute value is going to be negative, and in order for that to occur, x has to be less than -2. That's why I gave you an example of x equals -3, because -3 is less than -2, and this is what it is. So that is the first situation, or the first case. So this is case 1. Okay, I know this is new for many students. And then you have another case where whatever is enclosed in the absolute value is either going to be 0 or a positive number. Just so you know, the absolute value of 0 is going to be 0. The absolute value of a positive number is just going to be that positive number. So you have here x is greater than or equal to -2, right? Because if it is equal to -2 plus +2 is just 0. If it is greater, it's also -1 plus +2, just 2 minus 1, which is 1. And the absolute of that is just going to be 1, just like the absolute of 0 is going to be 0. So I'm just giving you like a check reference up front, but you had two cases. The first case is putting in the value of x so that everything in the absolute will give you a negative number. And the second case is putting in a value of x where whatever is enclosed in the absolute value is going to give you a positive number, because these are the two cases that can happen. So to solve this first case, what you have to do is actually this. You have to first of all so you have x plus 2 equals, and your understanding of absolute value is important going forward. I'm not going to go into detail as much anymore. I just went into detail at first, so everybody is on the same page. So you have x plus 2 and x squared plus 5x plus 5. Well, since we're dealing with a situation where x is potentially negative, we just put a negative here. And guess what? When you can either put a negative in front of x plus 2, or you can put a negative in front of x squared plus 5x plus 5. It's just going to give you the exact same answer that you're looking for. I just prefer to put my negative in front of x plus 2. So what you end up with is going to be negative 2, okay, equals to x squared plus 5x plus 5. So what you end up with is x squared, okay, plus 5x, okay. We're going to basically put all of them on one side of the equation. So x squared plus 5x, right? When I take this over here, that will be plus x, okay, and plus 5 plus 2. So what I end up with is x squared plus 5x plus, sorry, not 5x, plus 6x plus 7. So that is the answer that you have so far. And now that that's the case, you can also try the exact same situation for the right side of the equation, okay? So what you end up with is just x plus 2. Because we're dealing with a situation where whatever is in the absolute value is going to be positive in this case, we don't have to put a negative up front. So you have x plus 2, x squared plus 5x plus 5. So you end up with here x squared, okay, plus 5x minus x plus 5 minus 2. So you end up with x squared plus 4x, okay, plus 3 equals 0 equals 0. You can see the reason why this is much easier than the first one, where we would have had a fourth root and we'll be trying to figure out how to solve that. Very, very different. So now I'm going to just rewrite the new found equation. So this one is case 1. X is less than -2. So that would be negative value in absolute negative value in absolute symbol, okay? And then you have the case 2, where x is greater than or equals to -2, positive value in absolute symbol. Okay? Yay. So that's what we have. That's the case 1 and case 2. So now we can just put, let me change the color just to make things more beautiful. So you have x squared plus 6x plus 7 and x squared plus 3x, x squared plus 4x plus 3. So now we can basically solve for it. I'm going to be using what they call it. On the left hand side, I'm going to be using the quadratic formula, so which is just x equals -b plus or minus b squared minus 4ac over 2a. So that would be x equals to, we already know what our a value is here. A value equals +1, b value equals +6, c value equals +7. So we're just going to input that here, and that will be x equals to -6 plus or minus 6 squared minus 4 times 1 times 7 divided by 2 times 1. So x equals -6 plus or minus 36 minus 4 times 7 is 28, okay, divided by 2. So that will be -6 plus or minus 36 minus 28 is 8 divided by 2. So x equals -6, okay, plus or minus square root of 8 is the same thing as square root of 4 multiplied by square root of 2, because 4 times is 8, divided by 2. So that will be -6 plus or minus 2 root 2 over 2. Okay, so that is what x is right here. Now you have on the right hand side x squared plus 4x plus 3. And I'm doing it like side by side so you can see what is going on, just so it can be helpful to you guys, for those of you who like to compare stuff, especially since you're getting two values of x. So you have x squared plus 4x plus 3. You can you don't have to use the quadratic formula for this one. You can think through it using just the factorization method. I can change whatever is in the middle here to be x squared, okay, plus 3x plus x plus 3, because what the two factors would be 3 and 1, because 3 plus 1, positive 3 plus positive 1 is positive 4. Positive 3 times positive 1 is positive 3. So what we're doing here is fine. So I can just do factorization method. So to do that, what we have here will just be x, bring that out. So you have x plus 3, and then here we can just bring out 1. So that will be x plus 3 equals 0. So we end up with x plus 1 and x plus 1 and x plus 3 equals 0. So you end up with x plus 1 equals 0 is the same thing as x equals -1. Okay, and x plus 3 equals 0 is the same thing as x equals -3. Now guess what? On the case 2 basis, we have the positive value has to be what is like in the absolute symbol. We have a situation where case 2 we want x to be greater than or equal to, we want a situation where trying to think through it. We want a situation where x has to be greater than or equals to -2. Well, -3 is less than -2, so that's not good. But then guess what? -1 is actually greater than -2. So we have our x on the positive on the side of having a positive value in the absolute symbol, we have our x to be -1 because that's the only one that fits the case here, because x is greater than or equal to -2 and x equals to -1 is actually greater than -2. So that's good. But x equals to -3 is not greater than that. So we only pick this one here. Now, we're done with half the question. Now we're going to continue with the absolute value case for case 1, where x equals to -1. I'm going to redo that one here. So x equals to not x equals to -1, where we're going to be doing a case 1 where x is less than -2. So that's the other one here. X being less than -2. What we have so far at the bottom is just a continuation of what we're doing. I didn't continue because we didn't have space. So x equals to less than or equals to 2 root 2, all of that divided by 2. So that would be x equals to -6 over 2 plus or minus 2 root 2 over 2. So you have this and this and this and this. So what you end up with is x equals -3 plus or minus the square root of 2. So you have this. So you end up with these two cases, right? Because we have a plus or minus basis. We have -3 plus square root of 2, or x equals to -3, okay, minus -2. So we are trying to figure out what which one of them has a value of less than -2, right? Because we're dealing with the case 1 basis. So what we end up doing is to basically find what is the approximate value of the square root of 2. From what I can see here, the approximate value of that would be 2. I'm just trying to do it here on my calculator. I know it's less than 2 for sure. Square root of 2. That value is going to be approximately 1.414, right? So if we look at it, x equals to -3 plus 1.414. That value is going to be, when you think about it, you're going to have approximately, x is going to be approximately -1.6 or 1.5 something. And here, x equals to -3 minus -2. That will be -3 minus 1.414. That's something as x equals to -4.414. And this is going to be the answer right here, because this value is actually less than -2. But the value of approximately -1.6, right, in this particular case, so we're looking for x is less than -2. So the value of x approximately -1.6, and then the other one, x approximately -4.414. This case here, this answer here, -4.414, this is the answer. So this is how you solve it, because this one fits the case that we're solving for. So hence our 2x values would be, to write it in a better or neater way, the 2x values for both cases, there are 2x values for both cases, both the case where the x is less than -2 and also the x is greater than or equal to -2, you have the value x equals -3 minus √2, right? These are the values. That's for case 1. And also x equals -1. So this is how you solve it. I know that this kind of took a little bit of a while, but guess what? When you do more practice, it's not as long as it actually is. Actually solve it. I went into detail to teach you guys what to do so that all students can be on board, especially if this is the first time you're seeing a question like this. That's the whole point of taking my time to explain it. This is literally something, if you've practiced enough times, you're going to be able to be finish up in definitely less than the time that we did, a lot quicker. But it requires you to do some level of practice to be able to get there. So this is the explanation of what was done. Yeah, I wish you guys all the very best, but I also want you guys to try this in your own free time. You have x squared plus 4x plus 4 and x squared plus 3x minus 6, right? Try this question. I'm going to be solving this question in the next video, and I wish you guys all the very best. Hopefully this is helpful to an extent, but I wish you guys all the very best. So you guys should solve this. I'll see you in the next video. If you like this video, please make sure you hit the like button if you enjoyed and you feel like you want to subscribe. Please do subscribe, but don't forget to hit the notification bell. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.